Good morning, children. Children, let me take up the next topic, that is EMF of an electrochemical cell is also called E cell or cell potential. The difference between electrode potentials of two electrodes constituting an electrochemical cell is called EMF or cell potential. Children, remember, E cell or cell potential can be calculated in three different ways. Let me write on the board. Number one, look at here. E cell is equal to oxidation potential of anode plus reduction potential of cathode. Second one, E cell is equal to oxidation potential of anode minus oxidation potential of cathode. And the third method which we are using very frequently, that is E cell is equal to reduction potential of cathode minus reduction potential of anode. Children, in general, E cell is equal to E cathode minus E anode, or you can also write E cell is equal to E right minus E left. Remember, if E cell value is positive, then it is spontaneous forward reaction. Let me write spontaneous forward reaction. Suppose E cell is equal to negative, children, it is a spontaneous backward reaction, or you can say non-spontaneous forward reaction. Hope you are getting. If E cell is equal to 0, children, that means dynamic equilibrium, neither spontaneous forward reaction nor spontaneous backward reaction is taking place. That means it is in chemical equilibrium. So this is about cell potential, otherwise called E cell. Let me take up one particular example of a Daniell cell and try to write E cell for the Daniell cell. Children, let me represent Daniell cell. Look at here, how do you represent? Zn, yes, Zn2 plus aqueous, then salt bridge double line, Cu2 plus aqueous, Cu. This is what the cell representation for Daniell cell. Now you can find out E cell in three different ways, is it not? First one, what? Look at here, E Zn, Zn2 plus plus E Cu2 plus Cu. That means oxidation potential of a zinc and zinc ions plus reduction potential of copper to plus ion copper. Hope you got it. Now similarly I can write E cell is equal to E Zn2 plus oxidation potential of zinc minus, look at here, Cu2 plus oxidation potential of copper of cell. E cell, the most commonly used, look at here, E Cu2 plus bar Cu, reduction potential of copper of cell, minus E Zn2 plus Zn, reduction potential of zinc of cell. Remember, in a general, we write E cell is equal to E cathode minus E anode, or E cell is equal to E right minus E left. Children, this is about EMF of an electrochemical cell, otherwise called cell potential. Children, let me go for the next topic, that is Nernst equation, which is one of the very important topic for the examination from this unit, electrochemistry. In the year 1889, Nernst derived a quantitative relationship between electrode potential and the concentration of ions or electrolytic species, which is known as a Nernst equation. Children, first we are going to learn how to write the Nernst equation for the single electrode, and later we are going to learn how to write the Nernst equation for any kind of electrochemical cell or galvanic cell. Let me take up the first type, that is writing the Nernst equation for single electrode. Children, for writing the Nernst equation for the single electrode, let me consider one of the hypothetical reaction. Consider a general reaction. Look at here, Mn plus n number of electrons are going to get M. I can write a Nernst equation for this reaction in two different ways. Let me write the first one. Look at here, first method or way of writing the Nernst equation. Look at here, E Mn plus bar M is equal to E naught Mn plus bar M plus RT by NF into ln, natural logarithm, molar concentration of Mn plus ions upon concentration of metal. Remember, this is oxidized state, whereas this is reduced state. Children, the second method I'll write here. Second method, E Mn plus bar M is equal to E naught Mn plus bar M. Look at the sign here, minus RT by NF into natural logarithm concentration of metal upon concentration of metal ions. Look at here, this is reduced state, whereas this is oxidized state. Children, let me convert natural logarithm into logarithm to the base 10. Look at here, how do I do that? E Mn plus bar M is equal to E naught Mn plus bar M plus 2.303 upon NF into RT log of Mn plus upon concentration of metal. Hope you're getting. Similarly, I'll change here also. E Mn plus bar M is equal to E naught Mn plus bar M minus 2.303 upon NF into RT logarithm to the concentration of metal upon molar concentration of metal ions. Children, now you need to remember, look at here, R is gas constant. What is that? Gas constant whose value is equal to 8.314 joules per Kelvin per mole. Whereas N is nothing but number of electrons gained for the reduction. Whereas T is a temperature, is it not? Temperature, and it is 298 under standard conditions. And what else we have? We have F. F is nothing but Faraday. What is that? Faraday, whose value you know that 96,500 joules per mole. Children, what do? Now I substitute all these values in these two equations. Let me see. Look at here. E Mn plus bar M is equal to E naught Mn plus bar M plus 2.303 upon N. F is how much here? 96,500 into R is how much here? 8.314 into temperature is 298 log of Mn upon concentration of metal. Is it not? I further simplify. Look at here. E naught Mn plus E bar M plus, if you simplify that, you are going to get 0.0591 upon N into log of Mn plus upon concentration of metal. So this you need to remember. Then let me write other side also. Look at here, I'll write here. E Mn plus bar M is equal to E naught Mn plus bar M minus, directly I write the final value, okay, 0.0591 upon N into log of molar concentration of metal upon molar concentration of Mn plus ions. Children, this is what Nernst equation for single electrode. In general, let me write, look at here, in general, E reduction is equal to E naught reduction, means reduction potential, plus 0.0591 upon N into log of, what is this? Nothing but oxidized state, is it not? Oxidized state upon a reduced state of metal. Similarly, I can write here in a general. How do I write? Look at here. E reduction is equal to E naught reduction minus 0.0591 upon N into log of reduced state upon oxidized state. Children, these are the two important quantitative relationship between electrode potential and the concentration of ions you are supposed to remember for writing the Nernst equation for any other electrochemical cell. Children, hope you understood this. Let me go for the next topic, applications of Nernst equation. Children, you have learnt about how to write the Nernst equation for single electrode, is it not? Now let me proceed towards the next topic, applications of a Nernst equation. There are two applications of Nernst equation has been prescribed in our syllabus. Number one, calculation of cell potential or EMF of an electrochemical cell or any galvanic cell in that matter. Second one, determination of equilibrium constant. Children, let me take up the first one, calculation of cell potential of an electrochemical cell. For that, let me consider one of the simplest electrochemical cell or galvanic cell, that is Daniell cell. Children, Daniell cell can be represented as Zn solid bar Zn2 plus aqueous double bar Cu2 plus aqueous bar Cu. And you know how to find out cell potential or EMF of a cell by using a formula, that is E cell is equal to E cathode minus E anode. Look at here, in this Daniell cell, this is what the cathode and this is what the anode, is it not? Let me write E cell is equal to reduction potential of cathode minus reduction potential of anode. In that case, E Cu2 plus bar Cu minus E Zn2 plus bar Zn. Children, you can calculate EMF of an electrochemical cell by using a Nernst equation in two different methods. Let me take up the first method. Under that, let me write Nernst equation for copper of cell. Look at how do I write? E Cu2 plus bar Cu is equal to E naught Cu2 plus bar Cu plus 2.303 RT by NF into log of concentration of a Cu2 plus ions upon concentration of Cu. Look at here, instead of writing N, let me find out number of electrons gained during the reduction process of copper ions. Look at here, Cu2 plus takes up 2 electrons and get reduced to Cu. That means N is equal to 2 here. So let me substitute that. Look at here, I'll change as 2F. Hope you got it. Similarly, let me write Nernst equation for zinc of cell. Look at how do I write? E Zn2 plus bar Zn E naught Zn2 plus bar Zn plus 2.303 RT upon again 2 into F to log of Zn2 plus upon Zn. Look at here. Why did I write 2 here? Number of electrons gained for the reduction of Zn2 plus ion. Look at here. Zn2 plus takes up 2 electrons and get reduced to Zn, and hence N is equal to 2 here. Hope you got it. Once you write Nernst equation for copper of cell and zinc of cell, now you can find out E cell by using this formula. Let me write again. Look at here. E Daniell cell is equal to reduction potential of cathode minus reduction potential of anode. Let me substitute the Nernst equation of copper cell and Nernst equation of zinc of cell in this equation. Look at here. E cell is equal to E naught Cu2 plus bar Cu plus 2.303 RT by 2F, is it not, into log of molar concentration of Cu2 plus upon concentration of Cu minus, I'll write here, look at here, E naught Zn2 plus bar Zn plus 2.303 RT by 2F into log of molar concentration of Zn2 plus ion upon concentration of Zn. Hope you are getting right. Now let me write E naught Cu2 plus bar Cu minus, look at here, E naught Zn2 plus bar Zn. Now I'll take the common here, 2.303 RT upon NF. Hope you're getting right. Into, look at here, log of Cu2 plus upon Zn2 plus, here Zn upon Cu. Remember, the active mass or the concentration of zinc or any metal is equal to 1. So what do I do? Look at here. This will become, look at here, E naught cell. Tell me why? E naught reduction potential of copper cell minus E naught reduction potential of zinc cell under standard condition, that will be E naught cell. Hope you're getting right. Plus 2.303 RT by, sorry, this should have been 2F into log of, look at here, this is nothing but 1, this is nothing but 1 here, because active mass or the concentration of zinc is equal to 1 and copper is equal to 1. So log of Cu2 plus upon Zn2 plus. So you can write E cell, that is for Daniell cell, E naught cell plus 2.303 RT upon 2F into log of Cu2 plus molar concentration of copper ions upon zinc 2 plus ions. Children, if you substitute the value here, look at here, what you are going to get. E cell is equal to E naught cell plus 0.0591 upon this 2 into log of molar concentration of Cu2 plus upon Zn2 plus. Remember, the value of R is equal to 8.314 joules per Kelvin per mole, whereas T is equal to 298 Kelvin and F is equal to 96,400 joule per mole. Children, this is the one method of writing the Nernst equation for calculating EMF of Daniell cell. Let me take up the next method also. Children, let me take up the second method of calculating EMF or cell potential of any galvanic cell, in this case Daniell cell, by using Nernst equation. Second method, Nernst equation for copper of cell. How do I write? Look at here. E Cu2 plus bar Cu is equal to E naught Cu2 plus bar Cu. I'll change the sign here, minus 2.303 RT upon NF into log of, look at here, concentration of metal upon concentration of metal ions. Is it not? So let me find out N here. N again, how much here? N is equal to 2. So what do? I'll put 2 here. N is nothing but number of electrons are gained for reduction of Cu2 plus into Cu. That means 2 electrons are gained here. That means N is equal to 2, that I have shown here. Hope you got it. Similarly, let me write Nernst equation for zinc of cell. Look at here. E Zn2 plus bar Zn is equal to E naught Zn2 plus bar Zn minus 2.303 RT upon 2 into F, the log of molar concentration of zinc upon molar concentration of zinc 2 plus ions. Okay, and now once you write this, now you can go for finding out E cell, is it not? And what is that? E cell is equal to, what is that? Reduction potential of copper of cell minus reduction potential of zinc of cell. Is it not? Look at here. Let me substitute here. E cell is equal to E naught Cu2 plus bar Cu minus 2.303 RT upon 2F into log of concentration of a Cu upon molar concentration of Cu2 plus minus, look at here, E naught Zn2 plus bar Zn minus 2.303 RT upon 2 into F into log of concentration of zinc upon molar concentration of zinc 2 plus ions. Hope you are getting. Look at here. E naught Cu2 plus bar Cu minus E naught Zn2 plus bar Zn. Is it not? Hope you are getting. Now I'll remove the common here. Minus 2.303 RT upon 2 into F. So in that case, log of Zn2 plus upon Cu2 plus, you can write this also, concentration of copper upon concentration of zinc. Now you know that active mass of any metal is equal to 1. In that case, look at here, E cell is equal to, this will become E naught cell, is it not? E naught cell minus 2.303 RT upon 2 into F. Look at here, log of molar concentration of Zn2 plus upon molar concentration of Cu2 plus. Why? Because concentration of metal is equal to 1. Now let me substitute the value of R, T and F here. E cell is equal to E naught cell minus 0.0591 upon 2 into log of Zn2 plus upon Cu2 plus. So this is what Nernst equation to find out E cell of galvanic cell or any electrochemical cell, in this case for the Daniell cell. Remember, the value of R is equal to 8.314 joules per Kelvin per mole and T is equal to 298 Kelvin temperature and F is equal to 96,500 joules per mole. Okay, so these two formula you are supposed to remember in order to find out the cell potential or EMF of an electrochemical cell or any galvanic cell or voltaic cell also. Children, let me consider a general redox reaction involving transference of n number of electrons. Let me write the reaction A plus B giving rise to C plus D. Children, let me write Nernst equation for this. E cell is equal to E naught cell plus 2.303 RT upon NF into log of concentration of A raised to A, concentration of B raised to B upon concentration of C raised to C into concentration of D raised to D. Or you can simplify this, E cell is equal to E naught cell plus 0.0591 upon N into log of concentration of A raised to A, concentration of B raised to B upon concentration of C raised to C, concentration of D raised to D. Now, by substituting the value of R, T and F, you got this equation, is it not? And let me write one more method. Look at here, E cell is equal to E naught cell minus 2.303 RT upon N into F log of, look at here, concentration of C raised to C, concentration of D raised to D upon concentration of A raised to A, concentration of B raised to B. Or you can simplify by substituting the value of R, T and F. You are going to get 0.0591 upon N into log of concentration of C raised to C, concentration of D raised to D upon concentration of A raised to A and concentration of B raised to B. Remember, a value of A, B, C and D along with the N, that is number of electrons gained, can be obtained from the balanced chemical equation. Children, by going through this, you can easily find out E cell of any kind of electrochemical cell. Let me take up some of the example, then you will understand how to find out E cell by using the Nernst equation. Children, let me give two homeworks for you. Number 1, write the Nernst equation for the following cell: Cu bar Cu2 plus double bar Ag plus bar Ag, and this is what the balanced chemical equation. The second one, write the Nernst equation for the following cell: Al bar Al3 plus double bar Na2 plus bar Na, and this is what the balanced chemical equation, the redox reaction for this cell. Children, just now you have learned how to write the Nernst equation for general redox reaction. Children, follow the method which I have learned under general redox reaction. You can easily write Nernst equation for any kind of electrochemical equation, provided you know the balanced chemical equations for that kind of electrochemical cells.